Solar storms pose a massive engineering threat to our electrical grid. So, let's get into the technical reasons why. To see just how high the stakes are, we need to start with a real-world case study, Quebec, 1989. It all starts at the sun, with a massive event called a coronal mass ejection, or CME for short.
Now this CME kicks us a very specific chain reaction, which ends up inducing electric fields right here on Earth.
So these fields create what are called geomagnetically induced currents, or GICs, which flow through our power lines.
The entry point for these GICs is crucial, the neutral ground connections of our Y-grounded transformers.
Right, so here's the big question for us engineers. How can a DC-like current mess with our AC grid?
The main problem is half-cycle saturation. That DC flux from the GIC pushes the transformer core over the edge. And this saturation, well, it has three really nasty consequences for the grid. First, you get harmful even-order harmonics. They can cause protection systems to misoperate, tripping key assets offline. Second, the saturation creates fringing flux. This leads to severe localized heating, which can kill a transformer.
And third, the transformer suddenly starts guzzling enormous amounts of reactive power, VARs.
All that VAR consumption, it can tank your system voltage, risking instability or even a full voltage collapse.
Okay, so that's the problem. What's the engineering solution to all of this?
Well, the most direct approach is pretty clever. Just block the GIC's path into the transformer neutral. And we do this using a neutral blocking device. It basically acts as an open circuit to the GIC.
Of course, safety is key. These devices have built-in over-voltage protection to handle any system faults.
But it's not just about hardware. A proper defense needs a multi-layered approach, from forecasting to operations.
Which leaves us with a big question. As our grids get more complex, are we truly ready for the next big one?